Hello and welcome to INA's CCI Service Provider version 5 Learning Path. Today in this course we would talk about OSPF version 2 with BFD. Now BFD, which is bidirectional forwarding detection, is basically a mechanism to identify link issues between two routers, basically a link failure. Now all routing protocols have a built-in mechanisms of detecting a link failure. For example, OSPF uses dead interval to detect a link failure. However, with just using OSPF's inbuilt mechanism of detecting a failure, the problem would be that OSPF depends on the dead interval, which means he keeps sending hello packets, right? If you look at OSPF network type point to point, in that the default hello interval is 10 seconds and the dead interval is 40 seconds, which means that if I send you a hello and you do not respond back with your hello, if you don't respond back in 40 seconds, I will declare you dead, which means OSPF takes about 40 seconds to detect a link failure. And imagine if I had a network type which was point to multipoint, or maybe a non-broadcast. There, the hello and dead is 30 and 120, which means it would take 120 seconds for OSPF to detect a link failure. This can cause problems in convergence because you want to find an alternate path as fast as possible. Well, with BFD, what happens is that BFD is its own mechanism. It is not dependent on any protocol. It is protocol independent, which means you can use BFD with OSPF, with ISIS, with EIGRP, with maybe BGP, and you can also use that with MPLS to detect LDP failures. So what exactly BFD does? How does it function? Well, BFD has its own control plane where it sends BFD control messages to the remote peer. If the remote peer does not respond back in the respective amount of time, then BFD instructs the routing protocol, which is OSPF, which would basically register with BFD, and BFD would instruct OSPF to kill the neighborship. So OSPF support for BFD over IPv4 feature enables OSPF to register with BFD to receive forwarding path detection failure messages from BFD. And these messages are sent by BFD once it does not receive a BFD control messages from the remote peer. Now to configure BFD, the command is pretty straightforward. You would just enable BFD for the process. Now you can enable BFD globally under the process for all your interfaces by giving the command BFD all interfaces, or you could enable it for just one neighbor on the interface by saying IP OSPF BFD. The best part about BFD is that using the time intervals that we can specify in BFD, I can detect a link failure as low or as fast as 50 milliseconds. Now imagine OSPF taking 40 seconds to detect a link failure. I could readjust OSPF timers to go as low as 1 second, because in OSPF, the lowest you can go for dead interval is 1 second. But what if I want to detect a link failure in less than 1 second? Maybe in 250 milliseconds, or maybe in about 750 milliseconds. I cannot do that with OSPF. With BFD, what's going to happen is I define a BFD interval that at how much time I'm going to send a BFD control message to my neighbor, in how much time I should receive the response back. And let's say if he does not respond back for 3 of my messages, I will declare him dead and I will instruct the OSPF process to drop the neighborship, which means now we can converge through another path. So to configure the BFD interval, the command is BFD interval milliseconds, where we define, let's say 150 ms, and the minimum response time, which again should be, let's say 150 ms, and then the multiplier would be maybe 3, which basically means that I will keep sending him a BFD control message every 150 milliseconds. I should receive a response from that neighbor every 150 milliseconds. And if I send him 3 of my messages and he does not respond, which basically means in 450 milliseconds, I will declare him dead. Like I said before, you can configure BFD globally for OSPF or under the interface. Now, here is an example of configuring BFD on a Cisco iOS router, basically an iOS XZ. XRV does not support BFD at this point of time. So maybe in the newer version, they would probably add that, but at this point of time, XRV does not support BFD. Obviously, in the lab exam, you only have virtual devices, so they would never ask you BFD for XRB. They could probably ask you BFD for iOS XZ. So here's the command to activate BFD for OSPF process, and it is done for iOS XZ routers. So the first thing that you would do is either you give the command IP OSPF BFD under the interface to activate BFD for the OSPF process. This basically tells OSPF to register with BFD. Or I could give this globally by going under the routing process and saying BFD all interfaces. The next step, the step number 2, is basically to go to the interface and define the BFD intervals. So here I have a BFD interval of 250 milliseconds. The minimum response time is again 250 milliseconds and multiplier is 3, which means if he does not respond back in 750 milliseconds, I will declare him dead. Basically 3 of my BFD control messages. To verify your BFD, the command would be show BFD neighbors detail. Here you would be able to see your BFD messages, how many control messages you have received, which protocols are registered with BFD, and what's your minimum interval time for receive and send, and if your state is up or down. So let's go to our routers and configure BFD with OSPF pre-configured. So we already have OSPF running between 2 routers. I will configure BFD between 2 XZ routers, and we'll see how BFD works. We'll see without BFD, the effect of it, and we'll see with BFD also. We'll also try and configure BFD on iOS XRB. Again, it supports the commands. You can still configure the commands, but the control plane or the state would not come up. Let's go and configure this. So I'm going to go back to my 3 routers. I have R5 here, which is an iOS XZ router. I have R6, which is also an XZ router, and I have XR1 here. So let's go and access all our devices. So if I do a show IP OSPF neighbor, at this point of time, R5 is establishing OSPF adjacency with R6. R6 is forming OSPF adjacency with R5 and with XR also. So 1919 is the router ID of XR1. 5555 is the router ID of R5. So let's go and configure BFD between R6 and R5, both iOS XZ routers. But first, we will check without BFD. Let's see what happens. So what I'm going to do is, I don't have BFD configured right now. I do have my OSPF neighborship. I am going to go to R6 and go to my interface 56, which is the link that connects to router 5. And I will shut this interface down. Let's now go back to R5 and look at show IP OSPF neighbor. I still see my neighbor R6 here. And for how many seconds would I see that neighbor? For 40 seconds, because my dead interval is by default 40, because this interface is a broadcast segment and the default hello and dead is 10 and 40. So only after 40 seconds he will declare the neighbor dead, which is a pretty long time from a production perspective where you want faster convergence. You want your neighborship to go down and come back up faster. So here, after 40 seconds, my neighborship went down. I can tune my OSPF to detect the link failure faster, but the minimum time that I can do that with is 1 second, because the lowest dead interval that you can specify in OSPF is 1 second. I could not go in less than 1 second. Only BFD will allow OSPF to kill the neighborship in less than 1 second. So let me go back now to R6, do a no shot, and this time I will configure BFD. Like I said before, I could activate BFD for the OSPF process by going to router OSPF1 and saying BFD all interfaces. But this will activate BFD for all its neighbors, all its OSPF neighbors. I don't want that. I just want BFD between 2 routers, which is R5 and R6. So instead of this, I would go back to my interface that connects router 5 and 6 and give the command IP OSPF BFD. the next thing that I would do would be basically define my BFD intervals. So that's going to be BFD interval, and I define my milliseconds, so I could go as low as 50 milliseconds. So let's try and give maybe 100 milliseconds, and the minimum receive time should also be 100, and maybe multiplier as 3, which means that now BFD is going to start sending control messages over that link, and he will keep sending every 100 milliseconds, and he expects to receive in 100 milliseconds. I will send 3 control messages. If I don't receive 3 responses, or if I don't receive a response at all, in about 300 milliseconds, I will declare him dead, and I will instruct OSPF to kill the neighborship. So as of right now, I have only configured R6. If I do a show BFD neighbors detail, you would see that right now my state is down, because obviously the remote side is not configured. For BFD to work, it has to be done on both sides. Let's now go to R5 and give the same command, interface gig 1.56 IP OSPF BFD, and then BFD interval would be 100, minimum receive time is 100, and multiplier is 3. Let's check my BFD neighborship now. Show BFD neighbors detail. This time my state is up. The registered protocols is OSPF and Ceph. Ceph happens automatically. But right now OSPF also got registered with BFD. So now BFD is constantly sending BFD control messages across that interface, and the remote peer should respond back, else he would instruct OSPF to kill the neighborship. Let's go and test this now. What I'm going to do is I'll do a debug BFD events, and I will go back to R6 and shut the interface. If you remember earlier, OSPF took 40 seconds to declare the neighbor dead. This time, if I go back and shut my interface, in less than 1 second on R5, I would see OSPF neighborship went down from full to down. Why? Because the BFD event got triggered, which basically says there was an echo failure in less than 1 second, basically 300 milliseconds. And I instruct OSPF that kill the neighborship. My neighborship is gone. It's no more there. And once R6 comes back up, BFD would instruct again to OSPF that the link is back up, you can bring your neighborship back up. And you would see that your neighborship comes up as fast as possible. As soon as the link comes up, the neighborship goes from loading to full, and my neighborship is back up now. And my BFD event shows that the OSPF got re-registered, and my state basically went back to up. So this is BFD with iOS XZ router. Let's look at the commands on XRV. So maybe I'll go to R6 and configure BFD on the link connecting to XR1. So again, interface gig 1.619. That's the link that goes to XR1. And configure IP OSPF BFD. And then give the command BFD interval 100. Minimum would be 100 and multiplier 3. If I check my show BFD neighbors detail, my neighborship with XR1 right now is down because I haven't configured XR1. But even if I configure XR1, it will accept the commands, but my state won't come up because at this point of time, the current version that we have in the lab, it does not support BFD. But let's try and configure that still. So we go to config T, router OSPF1, and we specify BFD, and we will specify our interval basically. So in fact, what I can do is exit out, just be under the routing process first, and we can specify the BFD interval and then go to the interface and activate OSPF BFD for that interface. So here I can specify BFD and specify your minimum interval, which would be maybe 100 milliseconds. So here it says that it should be a minimum of 150. So iOS XZ had a minimum of 50, but XRV has a minimum of 150. So let's give 150. and then specify BFD multiplier as 3. Now, to enable BFD on XRV, we must also give BFD fast detect. Now, I can do that globally, like how in OSPF I had something called as BFD all interfaces, or I could do it under the interface. Let's do it under the interface. So now I go back to my interface. So that's going to be under area 0, interface gig 0000.619. That's the link connecting to R6. And here I would say BFD and fast detect. Let's do a commit. If I look at my configuration now, show run router OSPF, you would see that I have the minimum interval set as 150, multiplier as 3, which means it can detect a link failure in 450 milliseconds. And under my interface, I have configured BFD fast detect. So let's go now to R6 and change the interval here also, because you want to keep it same. So interface gig 1.619, BFD interval would be 150, minimum would be 150, and multiplier as 3. So now it's the same on both sides. Let's check my state. Show BFD neighbors detail. As you can see, my state is still down, even though I configured BFD on XRV, because it does not support at this point of time. So as soon as the link goes down, if BFD control messages are not received in the right amount of time, BFD instructs the IGP to kill the neighborship. I hope this video was informative to you, and thank you for viewing.